Hello again. Today I would like to create another shader in Grasshopper using GhGL, and which is this outline shader, not just for one meshes, but as a post processing works on every geometry which is laid out on the display. So this works on anything that is on the display or on the space, 3D space, and you can change the thickness or color, or you can also kind of change the quality or the resolution of the outline. As you can see, you have this kind of gap on the edges here, but by turning this resolution parameter a bit higher, you can make it a bit more roundy, like these. This makes the calculation a little bit higher. So, but anyway, this doesn't. The shader used in this GhGL is not for animations; it's for static image. So I don't think raising up this resolution would cost too much in terms of calculations. So I guess making this higher value is okay, but just to show you, if you make this value low, you can have you kind of see a low res outline like these. Right, so that's what I'm gonna show you today, and let me just show you the algorithm behind this of this shader. So say you have this kind of geometries laid out on the 3D space. What you want to have is the outline, which is just outside those geometries, covering up like these. And in order to get this kind of outline, what I can do is to first get the depth map of each geometry. So by accessing a depth buffer, which you can get it as in default from the global variable, you kind of get the gradient value, the grayscale value of the depth map for the geometry which is on this 3D space, and making this, using that depth map as a mask, you can first mask out the pixels on the display where the object is placed. Then after that, you calculate you pick each pixels, like here, 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 and search for the pixel on the right side and left side, or top side, on the bottom side, or on the circular angle like these, and see if from this pixel to the right side or other direction, if you see any object in this range here. In this case, from this pixel, you don't see any object, you don't see any depth map mask on any of the directions, so you can say that in this space there's no outline be drawn. But if you look at this part, then the right side, right direction doesn't have any depth map mask, top, bottom not, but on the left side you have, it kind of touches the depth map mask right here. that means that so this point that you have picked up could be used as a outline position, outline pixel. So use draw this with specific colors like black to use it as a black outline color, and do the same thing for other pixels like here, 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 and as a result you'll have an outline covering up the object like this, which is derived from the mask depth buffer mask. So that's the algorithm, basic algorithm in order to create an outline from the geometry to the geometry, which is laid out on the 3D space. And so basically you need to have a pixel information, 2D pixel information for depth map buffer, and UV information in order to specify the position on a specific pixel. So keep that in mind, and let's try to recreate that. Right, so first of all, let's have some geometry on the space, just a simple one. So I'm just gonna create a rectangle and some size like 1000 or something, anything, and populate some points on a rectangle with a specific number of points, and then let's have a sphere and with some radius, and I am just going to, oops, that's a bit too large, and maybe reduce the number of spheres. Let's make the radius a bit random. I'll just put this sliders on the radius, the domain here, with the total number of random value be the same as the point number, or this one is just fine, right? And let's set the radius a bit bigger. All right, so let's go with these two in order to calculate the radius. Maybe I wanna set the domain to set the minimum radius as well. Okay, like this. All right, so let's try to do with this setup in order to create an outline. All right, let's also color this a bit so that I can see the edges a bit better. So I will use the preview, custom preview, with the HSL color, and let's randomize the color using the same number to the hue, then maybe set some light luminance to a bit lighter. Alright, so I guess this is okay. So let's try to go with these geometry to create an outline as a post process. So let's start by placing a GL shader this time, and let's first, for the vertex, I need to set a vertex position for this screen, which is the corner for each display screen here. So the left top position, right top, right bottom, and left bottom. And for that, I could create a point component and go to right click and go to manage point collection and create 4 points like this. And for each point, I'm gonna set the coordinate in order to set it as a screen coordination. And for the first one, it's -1 for the x, -1 for the y, -1 for the z. -1. Right, so the second point will be a 1 for the x, -1 for the y, and -1 for the z. Right, so the third one, it will be 1, 1, and -1. And for the last one, it will be -1, and 1, and -1. So basically, the x and y are the important numbers here, the coordinates here. So I think the -1 is corresponds to this in the left bottom position, I think, and the 1 corresponds to the right top position, I think, or maybe vertically different. Maybe this could be a -1 and -1, but it doesn't really matter. Okay, and connect this into the vertex input. And for the second input, I don't need a V color, but I am going to change it as a color without the V. And let's set some color swatch so that I can control the color of the outline. Let's set it to black as a default value, and I am going to add 2 more parameters input. One is to determine the thickness of the outline, so I'll name this thickness. And also for the second input, I am going to name it as res, stand as a resolution, it will be the quality of the outline, so that it won't break on the edges if it's higher. Okay, so the thickness, the thickness is a pixel thickness, so could be like from 0 to 100, I guess. It depends on the display's resolution. In this case, it's high HD, full HD, so maybe 20, maximum of 20 might be okay. If it's high res, more 4K display, maybe you might want to have more pixels here. Okay, for the resolution, it's the matter of how many direction you want to check from each pixels. So if I set it to 4, it's 4 direction, like top, right, bottom, and left. If it's 8, you have you're splitting the direction into 45 degrees. So such that let's go with 4 first, right? And let's dive into the code. And let's write some code here. First of all, so the one that I'm gonna create now is a post-processing shader. So first of all, I'm gonna delete this layout 1, and then set the GL position to this vertex position that I have set it here as a point. So, and I'm going to delete those world to clip, and just leave this as it is. And I think this will create the post process position that covers all the screen right here. And let's also delete this one. I don't need this one as well. Okay, so far I don't see any errors, so that should be fine. And go to the fragment shader and let's write some code that I need. Okay, first of all, I am gonna need to retrieve the color buffer and the depth buffer for this visuals or the objects on the screen, or the one or the visual that I am looking at the screen right now. So in order to get a color buffer, I can go to this menu and there should be a color buffer here. So get that. Also, I want to have the depth map buffer in order to check if there's in order to create a mask, whether there's a geometry or not, and whether to check if there's a geometry or not. And then in order to fill the screen, I need to get the size of the actual viewport. So I can also get that global variable from somewhere around here. This one, viewport size. Right. Now anything. So these are the three global variables that I can get automatically from using the GLSL, and then I need to import some of the parameter that I have set here, so which is color, thickness, and resolution. So first of all, color is vector 4, including alpha, and thickness, and resolution, which is a float number here. Right. And do I need these? I don't think so, so let's delete those. Okay, and let's also delete this one, but let's set some default color. Let's try to fill this display with red to see if this works. Okay, fragment. Okay, I think I need to change this to GL frag color. And no errors, but I don't see any changes. I think I need to press OK and re-enable this. Okay, it doesn't change. Alright, something. Okay, yeah, I think I need to, in order to make this as a post-processing shader, I think I need to go right click and set the draw mode to something different, which is right now currently this shader is being set to GL points, but I think I needed to set it to GL triangle fan. Now the colors has been filled with red. Now I don't want to fill this in red, so let's revert this. Let's comment this out for a while and start writing code in order to create a outline. Right, so first of all, I need to get the position of each pixels on the screen. So in order to get that as a UV, which is from 0 to 1 for U for X direction and 0 to 1 for Y direction, I need to calculate the UV by dividing the GL frag coordinate, which is a global variable again, divided by a viewport size that I have imported here. So viewport size. Now this will give me a range of a X and Y position, and from 0 to 1. And also using those UV this UV information, I I would like to get the depth information on each pixels from this depth buffer, which is a sampler 2D, which is like a texture data. So in order to get that, I can get it like vector4 buffer equals to texture depth buffer and UV. Now at this point I can test out whether if I have got the right information from the depth buffer. So let's draw the display with this buffer information. So I'll just collect those and create it as a vector3 and just use a buffer's x value to draw the geometry or the screen, and I can see that the depth has been correctly retrieved. Right, now what I want to do now is to create a mask from these depths buffer. So anything which is even a little bit darker than white, this means that there is an object out there, even if it's really far away, and even if it's really close to white value, there still is a geometry. So I want to check if the color of or X is even a little bit higher than the white, which means 1.0 in this case, then make it black. So the easiest way I could do that, I could use a if condition, but in this case I am going to make it a bit more simpler by using a step. So if it's something under 0.999, which is a bit less than 1, then make it 0. Then if it's greater than these value, then make it 1, which is white for this buffer value. Now buffer X, Y, and Z should be the same. It's just a grayscale image, so I'm writing like this. And what's the okay? Spell mistake. So as a result, if I use this value to draw the display right here, it should make the screen black and white. So anything higher than a white color will become, anything lower than the white color, which is lower than 1.0, will be black, and anything that's close to the white color will be keep it as a white. So seems like the masking is correctly done as like this, so that's good. Right, now next thing, I want to, so now that I have a mask information, I want to check for each pixels and look at each direction, like bottom, left, right, top direction, if the division number is 4 here, or the resolution number is 4 here. So let's do that, and for that I am going to use a for loop. So for let's use it as a float, I equal to 0 from I to resolution plus plus. Now let's also calculate the step angle for the depends on the resolution. So I want to make a direction like 360 degrees divided by resolutions for a step angle. So if the resolution is 4, then 360 degrees by 4 becomes 90, and if you have 4 rotations for 90 degrees, you'll get every corner covered for 360. So 90, 180, 270, and 360. All right. So let's first calculate the step angle by dividing the 360 degrees divided by div. Right, and also let's set it to cover it with the radians to convert it into a radians value. Right, now that I have a step angle, let's write a code inside here to actually get the direction. Right, and so let's first calculate, let's first create the direction for, depend on the angle. Let's say direction equal to vec2, and that is a simple trigonometry using cosine and sine for with the step angle times I and sine step angle times I. And after that, does this looks okay? Am I missing something here? Okay, all right. This should not be div, but this should be res. Right? Okay, now after this, I also want to multiply this with the value of thickness so that the direction will have a length of the outline thickness here. So let's multiply this to vector 2 by thickness, like this. Right? Now that should be good. Now the next thing I would like to do is to check the depths, or check the masked depths buffer color from any pixel that is calculated on each direction, which have been calculated here, created here. So if you're looking at this pixel here, see if that pixel here, and looking at the top direction, right, bottom, and left with the specific thickness, with the specific distance, and if the pixel that you have chosen or looking is black, then which means the pixel that you have chosen will be outlined. If not, if the pixel is far away from the mask and if you don't see any black depths buffer found on any direction, then we'll keep it as white. So that you want to do and in order to do that, you can actually sample the buffer. I'll call it buffer P, using the same function that I used here, texture, and from the depths buffer, or maybe just use the value here. Oh no, I mean this is okay, this should be okay. Yeah, so depths buffer, and I need to calculate offset UV. So first of all, I have the same value as this one here. So GL frag code .xy, and add it with the direction I have created here. So the point position has been offsetted to the specific direction using this calculation, and then divide this by viewport size like this here, which will create a new UV in order to, this will be a new UV in order to, which represent the point position which is offsetted from the picked pixel at specific direction. And now use that UV to calculate, sample the texture, sample the buffer like this, and as a result you'll have another buffer value which is like this. So let's also do a similar stuff like this to make it black and white. Let's call this value P and buffer P. So if this value is black, then you'll have an outline. But you also want to check if this original value, which is the original point position, is whether white or not. So the simple calculation could be check the difference between the original value and the offsetted value is larger than 0. If it's larger than 0, then it means either one is white. Then and either one is, another one is black. So which is on the point that you have been picked is on the close to the edge, the outline edge. So I can make it as a black part or the edge part, outline part. So I want to set some color value here, so I need to have some variable in order to set it as a color value. So let's set the color value default as 1, which means white. But if you find the pixels on which is on the close to the outline, then let's set the color to maybe multiply by 0. Right, now let's check by setting the color to here and see if I get the outline, and yes, I think I do. Looks like a flower here because I am only checking the 4 corners, so left, right, and top and bottom. But overall, I am getting the outline from the depth buffer. And if I increase this resolution to something bigger than 4, you can see that the resolution of the quality of the outline is becoming a bit higher, which gives a more looping, so need more calculation resource, but I guess that's fine in this case. Let's set the maximum to something like 60 and set it to a bit more larger value, and it will become more smooth outline. Okay, and the thickness also works, and that looks good. Now right now the original color is hidden, it's all become white, and that's not what I want. I want to overlay the outline with the original color, as well as I also want to change the color of the outline as well. So let's do that next. Now that is pretty easy to do. You just need to use a mix function, which GLSL has. So let's create a new variable called vec3 call3 and use the mix. And first of all, the original color, the outline color is this one here, color. So I will give the original, the outline color to the first input of the mix X, Y, Z. And then for the original color, I can get it from this color buffer together with this UV information. So the texture and color buffer UV XYZ, just get the XYZ. And then for the switching, so if the value is 0, then the color will be used. If the value is if the value on the third parameter is 1, then the texture color, the original color, will be used. And that is the color value that I have created here. So if the 0 here, if the color is 0, then I want to make it an outline, so in this case the color of the outline will be used. And if the value is 1, which is in this case, then the original color is used where there is no outline. So like this, and just replace this color 3 with this one, and voila, now you have got an outline on top of the geometry that you have placed by yourself. And you can change the thickness, you can change the resolution, and you should be able to change the color of the outline as well. And that's it. That's how you can create a post-process effect outline, which works on every geometry on the space. And works great. And you can keep the thickness constant compared to the toon shader toon shader that I have made before. Okay, so that's it. That's how you can create an outline shader using a GhGL in Grasshopper. Alright, thank you. Thank you for watching, and see you next time.